welcome to PodRocket, a web development podcast brought to you by LogRocket. I'm Noel, and today I'm rejoined by Carson Gross here to talk about a blog post he recently wrote titled Yes and. It's kind of a discussion on people thinking about AI from the perspective of people looking to enter the field and make life decisions on do they want to go into software still. I thought it was pretty good. I thought it was pretty insightful. But anyway, welcome to the show, Carson. I'm really excited to jump in.
Yeah.
What kind of, I guess, maybe just as a quick background, why did you think you were in a good position to write this article? Why did you feel you needed to get your thoughts down here?
There's so much insanity right now around the AI meme plex of okay, we're never going to need programmers ever again. Programming is done. It's a solved problem. And then on the other side, I'll never touch any software that has been touched by AI, or there's very little rational discussion in the middle. And so at some level, this was my attempt to try and think rationally about the situation, with the admission that I'm not an expert on AI. And I've been surprised at how much it's advanced in the last year in particular. And so I don't have a crystal ball or anything, but I just wanted to have something that I could point people to and say, look, this is my attempt at a rational way to address this problem or this situation, your question.
Totally. I have a suspicion that even those who are more skeptical initially, and maybe more so those who are more skeptical of AI initially, are they're faced with this thing that we've all noticed in the advancements, how much better just the LLM text generation has gotten over the past 6 months. How are you kind of internally balancing this surprise at the progress against this kind of confidence that there's still going to be work that needs to be done?
Yeah. I think in the article, one thing I touch on, and this is something that a lot of people say, is that going from programming in a high level language, and when I say a high level language in general, I mean something in the family of C or Java or Python or something like that, where you're not at the assembly level. I teach the systems class and the compilers class at Montana State. And so I'm pretty familiar with that world and exactly what the transition between a high level compiled language and assembly is. And so what you'll hear people say sometimes is, okay, this is just like us moving up from assembly to a high level language. Now we're moving from high level language to prompting or programming in the English language. I don't agree with that. Because while I'm not an AI expert, I know enough to be dangerous. I know enough to say that the content that comes out of an LLM for a particular prompt is stochastic. You have no guarantees of what you're going to get, in a way that's not true of a high level language being compiled to assembly. When you talk about compilation step, you're talking about a deterministic situation. And also the target architectures, the number of choices possible when you're talking about going from a high level language to an assembly language or to a machine language target is relatively constrained in a way that's just not true with general software. And so I think those are two things that make that comparison, or that simile, I should say. I guess count comparison as well, but the simile, it's like that. I think those are two things that really make it dramatically different. And different in a way that one thing I try and say in the article is juniors have to write code. I know this is mostly seniors, but seniors need to hear that. The juniors need to write code, because if they don't write code, they can't read code. And if you can't read code, you're at the mercy of an LLM. And I know there's a lot of pure vibe stuff out there right now. And I've done some for demos for classes, and it's worked reasonably well. But for mission critical things and for business critical things, you got to understand what's going on under the covers. Now, do you have to, again, I can be the devil's advocate here and say, do people understand the assembly? No, but that's a different class of problems, allowing an LLM to generate, for example, your business logic. And I've seen enough LLM just flat out lying, for lack of, you can't lie. It's not sentient, as far as I can tell. But just saying, yep, I'm done. And then I go and look at it and I'm this is not what I was talking about at all. And if you can't read the code, you're not in a position to make that judgment in any meaningful way. I do think that there is the possibility of the way the programming is done changes. I think LLMs make they make code very cheap. As an example, I used to be very down on unit tests, and I would recommend integration tests. So, like at the API level, and then try not to mock things out too much to get tests that hopefully stand the test of time and don't change. My criticism of unit tests has always been as your implementation changes, then,
Yeah.
they
Change
break
one
some.
parameter, you've got to change, 200 tests
Exactly.
somewhere. Yeah, yeah. Mhm.
Exactly. And the unit test people would say, well, you just throw the tests away. And that's true to an extent. But then the reality is, particularly if you're new to a code base, like you come in, you break 200 tests. Do I throw these away or did I really break something? Like
Exactly.
it's
It's
very
hard, and
different.
it becomes hard to know if there's enough complexity in those tests in the system
Yeah.
overall.
And
Yeah.
as I think Stalin said, quantity has a quality all its own. Like when you've got too much, like you've got a bunch, it's got its own quality to it. So, anyways, and I wonder if LLMs change the calculus there because it's so easy to regenerate a unit test suite. So maybe it's less difficult. Like maybe it's easier to analyze, okay, is this breaking because of an implementation detail or because I actually broke something fundamental? I think it is going to change the calculus on some of these things for sure. But as I say in the article, I'm less convinced that like coding's done or something to solve problems. What you sometimes hear people. I just I don't know, man. Like someone's gonna have to understand the code, and I think the way to be able to read code is to write code. Like you have to write code to learn how to read it, and so that's again why I say the juniors have to read the code.
Yeah. Yeah, no, I think that there is a real risk there. You use the phrase or the term, the sorcerer's apprentice trap in the post.
Yeah.
I guess I'm curious, just real quick. Is that like a known turn of phrase? I thought that was a very clever. Uh,
No, that's just the thing that always the vibe bros just in my mind every time for whatever reason, like the scene from Fantasia just pops into my head of this person that has no idea what they're doing, but is like powerful for reasons they don't totally understand. And
yeah,
then it
yeah,
gets completely out of control and they can't. And there's like, it's just confirmation bias. But I think like the head of safety at Google's AI was like installed whatever the claw thing is and
yeah.
gave it
Was
access.
this the email thing? Was this the?
Yeah, and it just
Yeah,
started
yeah,
deleting her emails, and it's like it's confirmation bias. It's one of those things that's like almost too good. Maybe it's an AI story just made up to make me feel better about
yeah,
things,
yeah,
but
yeah.
it just
Mhm.
that's a classic example. It's cool. Don't get me wrong, it's really cool and very powerful. And I in the article I talk about how I've been using AI and I found it very effective. It's helped me improve my classes quite a bit, and it's helped me plan changes that I want to make that I wouldn't have been able to plan otherwise because I just don't have the bandwidth to do the analysis and stuff like that. Very effective for me. I don't want to say it's not like I think there's definitely something there, but I just think I was trying to give a more balanced perspective on it. And in particular, and this is against my self-interest at some level, like it'd be better if no one knew how to program and like you and I were the only people left that knew how anything worked. Like it would be better. And maybe that's part of the motivation of some of the people out there who are like, don't be a programmer. That's like the hope that like we turn into these highly paid COBOL programmers or something like that. My kids and my friends' kids, like I care about them, and I think there's going to be disruptions in the interest or in excuse me disruptions in the industry, but the industry is not going to go away. I have a hard time seeing that, and in fact, I could see it going the other way. I could see there being more need for programmers because of the ubiquity of AI. What's one of the big stories right now in AI? SaaS is dead. Everyone's going to have their own. No one's going to pay for anything because they're just going to make their own SaaS thing. I think that's very short sighted because 70% of the value of SaaS is that you don't have to manage the dang thing and deal with the bugs and all the rest of it. Now, there's a lot of really bad SaaS software out there, very abusive, user abusive SaaS software out there. And so maybe this is like a market dynamic that helps change that fact. But if that thesis is true, then you're going to have programmers. Yeah, it's not going to be a business analyst like keeping up the mission critical piece of software that makes the business go. It's going to be someone technical who understands what's going on, understands the deployment. So that's one thing I talk about in potential takeaways is, for lack of a better term, working on systems architecture, understanding systems architecture, like how a deployment works, how a database gets backed up and communicates effectively with a middleware and all the rest of it. I think that's going to become more valuable over time. And maybe raw coding becomes less important. I still think you have to write code. And so juniors have to write code to learn how to read code. Seniors have to write code so that they don't become dumb. Because if you don't exercise your brain, you're gonna just turn to the MIT study already has shown. Don't engage with the material you're cooked. So it's just a lot of things like that I'm trying to, in that essay, I'm trying to like bring together and be like, okay, let's analyze this in a rational way and think about like some of these claims from a rational standpoint.
I'm with you on, I guess, several points there. I want to go through a few of these. In the beginning of that explanation, you were speaking to how we were talking about testing originally, and how before it was like, well, there's a cost to maintaining tests because having to write them and edit them is a lot of overhead. But now we have probably the most effective paradigm for writing code ever. But again, it's hard for a human to understand and go in and read all of this. As like an educator, you probably focus on this problem more. Do you think we'll see an evolution of coding best practices as a result of most development work being like agentic or largely augmented in some manner? Is it going to change our paradigms and how we think about abstraction and all that stuff?
Boy, I just don't know. I don't think so, because I think there's the silver bullet essay that every computer programmer and probably every person in the technical industry should read, the No Silver Bullet essay. And they talk about accidental versus essential complexity. And one of my arguments in favor of high level programming languages is that they actually eliminate most of the accidental complexity when compared with like assembly programming, which is just miserable and you got to keep track of a million things and all the rest of it. And do nothing about accidental complexity. They just make it easier to generate the solution. They don't eliminate accidental complexity, or they don't eliminate essential complexity from the problem. And even worse, they're a stochastic solution. And so you're throwing chance in there, like quite explicitly, like you set a temperature on the model and you just try and get it right it's very different than the high level to assembly job. And will that change the fundamentals of computer programming? I don't think so. I think it's still going to be controlling complexity. That's the big thing. That's the other main point that I make in the article, is that computer programming is about two things: solving problems with computers, and then doing so in a way that minimizes or at least manages the complexity effectively. Prompts don't necessarily do the second. They do the first increasingly effectively, but it's usually not the first thing that matters. It's the maintenance. Code is typically read more than it's written. At least it has been in the past. I don't know if that's going to change. But I just feel like it doesn't. If you buy the essential versus accidental complexity split as being like the core thing, I don't see how fundamentally changing that. And I see a lot of situations where it's making things significantly worse because you're able to generate so much code. Like, you don't get that feedback loop that you used to get. There used to be, so complexity tends to grow exponentially, or at least geometrically, but I think exponentially on most projects. And you used to get feedback on that. Like, you'd hit this spot where it's like,
This hurts
really,
now.
this is really hard to make changes in this system. And we've made some bad decisions. Maybe we need to decouple things and so forth. And that level of that, and when you're just generating code, you don't get that feedback necessarily. You can get lost in the sauce prompting a whole bunch. I've gotten lost in the sauce with some projects, but you don't get that really visceral feedback. And what if there's a lot of accidental complexity bubbling around under the surface because of bad choices that were made by a fundamentally stochastic system? Like, if you can't read the code, I think you just still, all the old rules still apply. I think at some level, maybe different, maybe in a different context, and maybe not as much and so forth. But I think controlling complexity is still like job one for seniors in particular. Is okay, like, we can't let this get out of control. We can't fall into that Sorcerer's Apprentice trap where our code, there's a term in football, you've outkicked your coverage, like when the punter kicks the ball like too deep And it just gives the guy a chance to catch it and read the field and makes it
Figure
much
out.
easier for
Yeah.
him to return the punch. And I feel like it's very easy for that to happen now in computer programming. You're just like, look at this thing that I built and it's cool. Like, how does any of it work? I have no idea.
Yeah.
Okay,
Yeah.
maybe.
I think most would agree that is a problem right now and is something to be cognizant of for sure. But I think where opinions more likely differ is like, where along that line are we willing to have code that is, and like, I'm pretty sure that's right. The machine made reasonable decisions here. It feels like we've optimized a long time on kind of language paradigms and our best practices being oriented in such a way to minimize complexity from the perspective of just like a human reading and writing code. Do you think that there's going to be like any kind of fundamental changes there that may be like an easier abstraction? So it's like we can understand what something is doing without needing to kind of look through code like we did before because we're confident enough in what the LLMs spit out? Or is it always going to be LLMs writing code that we kind of designed to be human, readable and writable, and then us having to walk it? Is there a potential for there to be some separation? And we'll trust the docs or whatever the LLMs.
I think there's an argument for testing. Even if I don't understand the implementation, I'm going to look at the tests and understand the tests. And I could see a world. I wouldn't want to work at this company, but I could see a company that says, look, your job is to understand the tests. Your job is basically to become more of a QA/manager of these rather than a coder. There's a part of me that dies inside thinking about that because I like writing code for the most part, not always, but for the most part. And I like well-written code that looks right, in my opinion. A lot of people don't like the way I write code, but I feel like if you can't look at the code and see what and understand what it's doing, I don't know. Is that any different than using a library that you don't understand because you're at some level more responsible for the code that's there?
It
Like
feels different though. Yeah.
it feels different because you're deferring to an actual expert, or at least in the past. Who knows now?
Yeah. You
But
assume the library's battle tested versus this is a vibe thing that is probably right. Like there's
right.
there's an interesting like trust barometer. Do you trust the library more or do you trust something that LLMs spit out? I'm not sure where that scale is right now.
Yeah,
Yeah.
yeah, it is. And again, the warning that I would put out to people, especially business people that don't really understand or care too much about computer programming, is like there is a complexity curve that goes at least geometric and probably exponential. If your LLMs, like I've seen this in not my work environments, but friends come to me and been like, these people in my company are just coming in with these 100,000 line LLM generated PRs that they're like, look, I fixed all this stuff. And it's like, don't even, that's crazy to do that. I'm not saying you can't do that with what I think Ladybird, someone redid their JavaScript implementation in Rust using LLMs or something.
Yeah, what was that? It was Cloudflare. Well, maybe this is something different. Cloudflare redid like a Vite version of React.
Okay.
Yeah, anyway.
All right, whatever.
Yeah,
and I'm not saying that can't be done, but I would be very skeptical in most companies where you're not dealing with like super high-end engineers to let something like that in, because you go from one state to another state. And I've just seen so many subtle changes, particularly like this was in a platform level thing. Like it was something that the rest of the company was built on top of. And then real money's involved. Like that is not a good idea. That is a bad idea. You guys need to be much more incremental and like much more. The term that I use in the article is deliberate, like being deliberate rather than just fire up a prompt and should go shop on Amazon or whatever, which I'm guilty of. I'm guilty of it. But I think like the responsible people need to look at that very skeptically. I think the part of the problem is like, it's like there's always been this emphasis on speed in coding, particularly I think for juniors. Like junior programmers are really impressed by people writing code fast. And I think business people are really impressed by people writing code fast. And when you get more mature and more of a senior, you're like, it's not really how fast you write the code. It's how you write the code. It's the code that you wrote. What code do you choose not to write is often like one of the most important
The
things.
code golf game is like
Exactly. Yeah, not
yeah.
even golf, just like the
No,
willingness to say, we're
yeah.
not doing that feature
Mhm.
because
Yeah,
I
yeah.
know it's a disaster and it's not going to add enough value compared to the complexity of that feature. And that I think is like in the excitement right now, that style of thinking is, and we go through, I feel like we've gone through this probably 4 times in my career where some revolutionary thing comes out and everyone's going to change everything. This appears to be more revolutionary than those ones right
Yeah.
now from where I'm
Agreed.
sitting. Like it appears to be more significant. This appears to be to me as significant as, for example, garbage collection. Like garbage collection in the history of computing, what are like the big things that like made a difference? Okay. Operating systems with processing
Yeah. Right, right.
isolation. That was a
Mhm.
big one. High level languages. So moving up from assembly to like high level languages, and then garbage collection. And those three things are probably, oh, and then the function call abstraction. It was there in assembly, but not really. You had to make it up in your own brain. But then high level languages really formalized that idea. So those are like the big things where you really saw a 10x in productivity. I think the all for my career, like by the time I came in, garbage collection was like pretty normal. I started as a Java programmer, so I was used to garbage collection. And it's been like object oriented programming, 10x everybody. That didn't pan out. Like test driven development's going to 10x everybody. That didn't really pan out the way patterns are going to, the patterns movement is going to, that didn't really pan out. So this may be the first time I've seen technology that might 10x people, but the 10x I'm not super pumped on from what I've seen so far
Yeah.
because
Yeah.
it doesn't feel to me like it makes people like able to deliver 10 times the value. maybe 10 times the code, but not necessarily 10 times the value.
It does depend a little bit on domain. It's like the same thing you keep seeing where there's like ad like just vibe coding advocates. Look at this crazy project I spit out in an hour. And I think you can do that 10 times faster than before. But like an overwhelming number of those are it's like landing pages and very simple CRUD apps and things like this. And as soon as you start ramping up on that the complexity curve, I think, and I, even just anecdotally from having worked on a kind of spectrum of apps we have, like internal tools and stuff we're working on. As you start climbing that curve, you hit this point where it's like the returns diminish extremely quickly to the point that you're underwater. And it's hard to know, I think, where a given project falls. So that's like a muscle we're all trying to train right now to figure out like, when is this a problem I should delegate versus I need to go in and be intentional here?
Yeah, no, I know. That's another thing that I say is I think we're still trying to figure this out. Anyone who's super convinced about one thing or the other right now is, I think, lying to themselves because I know for a fact the way that I code now is different than the way that I coded 6 months ago,
Oh yeah, I've been saying the same thing. Yeah.
particularly for code that I just don't care too much about. I don't want to say I don't care about it, but demos for my students. Like I've had to change my brain because it used to be I'd be like, oh man, it'd be so great if I had a demo for this. And now it's like, Carson, there's no excuse for you to not have a demo for this
Yeah.
because you
Yeah.
can just literally type the words that you just said into a box and it'll create the demo. And the demo is going to be right like 80% of the time. And then it'll be close enough that you can probably get it to work out like another 15% over time. And so that's a very different headspace to be in than I used to live in. Just last semester, I teach. So my compilers class, we target the JVM, we target Java bytecode. And one of the things that's hard to understand in the JVM, the way JVM works is there's this thing called an operand stack and these slots. And that's what a frame, like a function frame looks. And it's really, there's a couple of diagrams on the internet, but there's not really a good visualization of it. It did this, but I don't know anything about TUIs
Yeah.
and I don't
Yeah.
want to deal with it. But I
Yeah.
hammered in the background while I was doing other work. I hammered on Claude for a couple days and got something that's very good, and it's okay. Like my students have a much better understanding now of the JVM because of that. I don't know what to say. Like that's a thing that happened.
It's hard too because like those are low stakes. If there's a bug in there and it's like whatever. Like it's better than having no demo. And if you're not iterating on it long term, because I feel like that's a thing that I'm struggling with. Is I have some tools, stuff I've written for myself, and it's like when I come back to it and I'm trying to pick it back up, and I need to do like a refactor, add something kind of fundamental. It's hard, especially if I don't have a good like test paradigm set up. It's not well exercised. It's like weird stuff will start breaking again, and in ways that I would never have expected it with human written code. Like, this page just isn't wired up to do anything anymore. We just skipped the implementation and you said to do, but you never told me about it. That kind of stuff, I think, can be frustrating.
Yeah, it's exactly. It's like you have to, and you don't know in advance like what the maintenance calculus is for a particular piece of software. That's really hard to do.
It's like the estimating problem. This has been a huge problem in computer science forever. It's like, where's the hidden complexity? You kind of don't know yet.
Yeah, I continue to believe that there's no silver bullet, but I don't know. I do one. So if you want to start, I'm trying to think. You try and think expansively about stuff. Okay, I tend to be pretty conservative. I'm an old guy, so I'm grumpy and like all the rest of it, right? But you do. It's good. A good exercise to be like, okay, let's take a step back and think about what are the weird possibilities that could come out of this. And I'm going to offer you two weird possibilities. Number one, what if universities, which have not done a great job of providing a lot of value in computer science, in my opinion, if there's any profession where going to college is not necessary, if you're a smart person, you can figure out computer programming. And at least in the past, you can go out and get a job. If you're willing to lie in your resume, that's probably still true.
Oh, for sure. Especially if we constrain it to things we've considered, like, engineering, like fields kind of thing, right?
Yeah.
For sure. Mm-hmm.
But I wonder if, ironically, if a university degree, and this is in my self-interest, so take it with a grain of salt, but I wonder if they might become more valuable over time if the universities commit to in-person testing. Because
forced learning.
So easy to cheat on everything now. It's so easy to cheat on everything code related that I wonder if university degrees are going to once again become signals for competence computer programming, because like you're forced to go and put your butt in a chair. And that's what I did. This semester I switched to in-person quizzes, which I'd always done online, because like, why would you do this old timey? It's dumb. And then I was like, kept getting the same answers, and I'd see like LLM poisoning between questions. It was just like so disheartening to see this stuff. And I'm like, okay, I guess we got to go back to in-person. So that might be an interesting unintended like outcome that comes out of this like new world.
Are you thinking that is strictly like comp sci, or do you think that's just higher ed across the board?
I think if the higher ed, because it's such a lumbering dinosaur, has all this infrastructure available for in-person testing, that might be the only thing that can actually give you an objective like measure of like how competent someone is. Like it's just one of these ironies of history that like by being so backwards in some ways, like actually having the desks and like we've got a printer that's an industrial printer. I feel like I'm back in the 1990s or whatever, but it's there. So I wonder if that might be something that comes out of it. And another one, and this is a little bit spicier, is I wonder if the real danger for AI is actually outsourcing. I wonder if AI changes the calculus on outsourcing software development to other countries. Because the argument in the past, and this isn't always the argument, but has often been like, look, I can get 10 programmers in country X for the price of one programmer in the US. Okay, but like now one programmer in the US with an LLM can produce 10x as much code. And you don't have this coordination problem with timing and like people trying to be up at night or whatever in order to communicate. So I wonder if it's going to change the calculus there pretty significantly as well. So a lot of like things that I don't see being discussed, that seems like that's a possibility to me. People, one thing at one point I make in the article is business people saying, great, we don't need programmers anymore. But I can just as easily see a programmer going, great, I don't need a business person anymore. I can have an LLM set up a Google Ads campaign as effectively as anything else. So why aren't I doing it?
I think this will bring us back to where we started in a neat way again, given that the impetus for this post you wrote was, where do I spend my time and energy? And I think, I don't think this is like a hot take, but I think engineers are probably having a little bit more intense experience in staring down the barrel of what AI is capable of, because our tools, as always, advance more quickly because we're building tools for ourselves. We know how we work, right? So it's easier for Anthropic to build tools for developers, as the developers at Anthropic to build tools for developers, than it is for accountants just kind of innately, right? Like they understand the game a little bit more. The way I've tried to ground myself here is if it's coming, if this massive replacement, we won't need developers anymore. If we don't need developers anymore, we're not going to need information workers in any capacity anymore. I don't see how we would really
Something that's
need.
capable of turning out a production SaaS system is probably capable of turning out a PowerPoint slide.
Exactly. Or doing your taxes or like you name it, like legal stuff. I don't know for certain, but to your point on the business plan, if the near singularity can pump out this a crazy complicated production SaaS system, I would think it could also give me a pretty effective Google Ads campaign. Do you think that's true, or do you think that software is a little bit more easily impacted by this? Because at the end of the day, we are just like writing text.
Lawyers write text, just fundamentally work with numbers and write some text. There's deterministic rules for accounting to an extent, anyways. Like, I don't see any knowledge based system being safe from AI automation if the goal is human replacement. One thing I've said this before, I didn't say it in this essay, I imply it, but I prefer to think about humans are an end, they're not a means. That's something that appears to be
Yeah.
deeply lost in our society
Yeah.
at this moment in particular.
You think they should be the end, but alas,
Yeah,
here we
like
are. Yeah.
they're not means, they're
Mhm.
ends. And
Yeah.
like it's so to me, it's like great, would you make people more efficient and you can do your job more effectively? Not we're gonna throw you out on the street. Good luck. I don't have a crystal ball. I can't say. What I can say and what I say in that article is effectively look, solving problems with computers is likely to remain a useful skill. The way precisely that skill is exercised may change, but it's going to continue to be a skill. And the world is very big. And there's a lot of companies and like places that need people that can use computers to solve problems. And so I don't think that AI changes the calculus too dramatically as far as what the work and the mental exercise necessary to get to be an effective programmer versus an effective prompter or manager of LLMs. I do think it changes the flavor a little bit. As I recommend in the article, I say working on communication skills, like your ability to write just prose in general, is probably going to become more important. But the fundamentals of computer science or computer programming, whatever you want to call it, of understanding what exponential time is versus linear time or log n, or understanding, okay, we should be using Redis for our cache for this database or whatever. Those things aren't going away. Someone still is going to need to understand that. And I think right now there is a little bit of an existential crisis. You can see it I'm off Twitter for Lent, but at the tail end, right at the tail end, before I kicked off, before I just closed the window, I just saw increasing mental break on
Oh no,
Twitter
Reddit's the
around
same
this.
way. Yeah, it's
Yeah.
just the online sphere.
So it's
Yeah.
okay. It's probably the skills that one picks up when learning to program computers are going to continue to be relevant. And if they're not relevant in the way that they're currently, just like, and this is one area where maybe the assembly metaphor does hold up. Like you knew how to program in assembly, so you had to learn how to program in C or Pascal or whatever. I didn't notice fewer computer programmers after that transition. So there were more, and there was a lot more slop at the
Yeah.
time. There was a
Yeah.
lot more. The assembling programmers grumbled a little bit about the inefficiencies and all the rest of it. So maybe there is a part of it holds up. Although, as I said earlier, I do think there's pretty big problems with that simile between those two things. I'm comfortable with my son saying, "Hey, I want to study computer science. I've got skin in this game." And I just think that way of thinking, the computer science mindset or the computer programmer mindset, the logical, being able to structure large systems to effectively encapsulate things is going to continue to be relevant, even if the way that we do things changes. I don't think it's going to change as dramatically as some people, but I think it will change.
I think it's probably a pretty wise outlook. People seem to be having the more tempered kind of like things are going to change. Anyone who's telling you exactly how is a little overconfident, and you should be skeptical.
Yeah. I think there's more to it than object-oriented programming.
Yeah. Yeah.
but maybe less to it than the function abstraction would be
Yeah.
my if I was gonna if right now, if I was gonna pin it, I would pin it between those two
Yeah.
as far as like how dramatically it changes things.
Yeah. And how quickly and all that. So
Quickly is different. Quickly is this is as fast as I've seen anything happen.
agreed. Like again, I think people are changing the way in which they do things very rapidly. I don't feel that I'm like have a glut of extra functionality that's been afforded to me just in my daily life or anything by LLM. So it's like, will the impact be quick? I'm doing things differently because I'm prompting and stuff, but I don't feel like I'm using technology that's far and away better kind of outside of that.
Yeah. I
So
think if I was to estimate what my and I think I'm in a pretty good position to lever I'm old. Old people aren't good at some things, but I have a lot of experience programming, and I would say that it's probably 2x what I can get done. Not at quality, but it's 2x what I can get done. And a big part of that 2x software, I don't want to call it throwaway, but software that I don't care as deeply about, like demos for students. That's the thing that like sticks out. How would my life be different if I didn't have LLM? I would not have nearly as many good visualizations for students about computing. Frankly, it's a little bit of a failure on the part of computer science that we don't have good visualizations for these things already. But okay, in the past, that required an artistic bent, and like it was tough to do well. And a lot of the visualizations that I have are pretty janky, but they're like good enough. And so that's where, if you look at like the extra, if I make two mainly content that I wouldn't have been able to create because of time constraints, and it's not necessarily the highest quality X. Like my best work is still working on lectures and organizing the lecture effectively, writing essays, working on htmx, which I'm not gonna let an LLM like just rewrite all that stuff. And I think the APIs that htmx presents to the outside world, that's like something an LLM isn't going to come up with. And I'm not going to let the make any decisions about that. I say that in the article as well. So that's a big deal. That's a big deal, but it's not a 10x for me yet. Maybe I'm cooked and not whatever, but I feel like I'm in a pretty good position to take advantage of these effectively. And that's, I'd say, where we are.
yeah, yeah, nice, cool. That feels as good a point to wrap here as any, Carson.
Sure.
Again, we'll have you back for talking HTMX stuff
Yeah.
as soon as we can, as soon as it makes sense. Is there anything else you wanted to leave listeners with, or do you feel that was a pretty good?
No, I think that's pretty good. The only thing I'd say is like right now there's like a tremendous amount of stress in the world, and rightly, and
Yeah.
like just everybody give everybody a break, including yourself. Like it's
I feel
gonna
it. Yeah.
you're like the sun is not going to stop coming up. Being a good person is going to continue to be difficult. And so give yourself a break, and especially give the people around you a break, because it's just, I see a ton of stress right now around AI, everything going on in the world, and all the rest of it. It's Lent. So I'm trying to like really work on myself. And I think we can't make other people be good people, but we can make ourselves be a good person. At least to an extent. So,
thank you for the words. And I need everyone telling me that I should relax that I can find right now. It's good. I appreciate it. Cool. But yeah, thank you again, Carson. It was a pleasure.
Yep. Have a good one. Bye-bye.